We are looking at chapter 21a, the lymphatic system. Okay? All right, first question is be able to explain the function of the lymphatic system. So here we go. Look at that. Already highlighted for you. What does it do? It picks up extraneous fluid that had leaked out of your capillaries. And we'll show you a picture of that in a second. So it picks it up so that you don't have edema in an area of your body. And we return it back to the subclavian veins so we can put that water back inside our blood supply. Number two, it is used for absorbing lipids. Okay? Inside your intestines is called the lacteal. And the lacteal picks up the lipids from the food you've eaten, whereas your capillaries pick up the carbs and the proteins, the carbs and the amino acids. But the fats go into the lymphatic system. And last but not least, it is part of your immune system because the B cells and T cells, two different types of white blood cells, lymphocytes, they live inside these little structures called, the lymph nodes, okay? And that's why as the lymph is going through, it gets cleaned out, got it? That's why on my test you'll see the lymph nodes are the structures that filter, okay? All right, super. So, remember, when the blood is being delivered to your capillaries, we learned this in chapter 20, to push out the nutrients, we have to push it out with water. We call that the hydrostatic pressure, got it? And then as the blood moves on, osmotic pressure takes over, pulling the fluid back in so it can go back to your blood, got it? And back to your heart. But do we pull out all of the fluid that leaked out? No, we actually leak out how much more?
1/3?
About 3 liters. Okay? We lose 3 liters out of our capillaries in our body every day. Well, if you keep doing that, that's like a 3-liter Coke getting in your arms and legs. Yeah, you'd be all puffed out. The reason we're not puffed out is because that's what the lymphatic capillaries are for. Got it? And we call them blind-ended because they start here. Got it? These capillaries are part of a circulatory system. Got it? This is a one-way system. And as it brings that fluid back to our vena cava, through the subclavian veins, they go through these lymph nodes, which is where the B and T cells and other macrophages are located. Okay? And since this is coming from all of our body, it will pick up anything that may be infecting our body. It picks up the bacteria from here and the viruses from here, as well as dead tissues. So the macrophages will eat up the dead tissues and clean it up before that cleaner blood makes it back to your circulatory system. And the T cells and the B cells will do their job identifying bad guys. 10-4, which is what 21b is about. Fair enough? Okay. Alrighty. Trace the flow of lymph. Well, that's pretty straightforward, but if you want to, you can look at it this way. See how these blind-ended capillaries are sucking up the fluid that's in between? Okay. Alright, so I think there's a whole list here. So that's just like lab. Remember we did the lab video? Okay. See, the capillaries bring it into, obviously, afferent, going up towards the heart, okay? Go through the lymph nodes, alrighty, and make it up, and then you go to a trunk, which is a large lymph vessel. Remember we have jugular trunks and subclavian trunks that we talked about in the lab picture? And then finally it goes into 2 ducts. Got it? That's the key. The duct is the last part before it enters the subclavian vein. All right? And I think there's a picture here. Yes. See? This is called the right subclavian duct on the right side of the body. Remember, my right. Okay? I had a nice conversation with my students this morning. Well, how can you tell which one's left and right? Because it's the patient's left and right. Okay? And then this is the thoracic duct. Alrighty? This picks it up only from the right side of your head and right arm. This picks it up from the left side of your body and your two legs. Alrighty? And see this bulge right here? That's called the cisterna chyli because chyle, C-H-Y-L-E, is fat. From where? From my digestive system. See? It gets pulled in and it kind of sits there and then it moves on up to your blood. Alright? So because remember, that's one of the things that your lymphatics do. It is the one that absorbs the fat from your diet. Okay? Alright, so that's how you do that. Okay. What influences how lymph moves? In a nutshell, exactly the way venous blood moves. Got it? Think about it. How is the blood from your feet going to make it all the way back up here? Well, there is no heart down there pumping the blood up. So we need something else. And we'll see. I know it's in here. Yep. Here we go. This is how the lymph is going to flow for us. We need contraction of nearby skeletal muscles. Whenever you're moving your arms and moving your legs, your muscles will contract, and as they bulge in the center, they push against veins, or here, they'll push against a lymph vessel. 10-4? Well, when you push against a tube, the fluid on the inside can only go in two directions, up or down. How come we don't go down? Because guess what we have inside our lymph? One-way valves. Just like our veins, they're like this. Got it? And when the blood flows this way or the lymph flows this way up, it pushes out of the way. But when it wants to come back down, it slams shut. Okay? Semi-lunar, half-moon valves. Okay? And I've said this before in my videos. If a semi-lunar valve works to make blood go up the aorta and not back, or up the pulmonary trunk and not back, why not use it in your veins? And if it works in your veins, why not use it in your lymphatics? Got it? Nature doesn't have to make 16 different valves to do the same job. All right? Okay. So that's one of the things. Let's go back to our... Okay, so next, the fact that when you change the shape of your chest while you are breathing, you are creating a suction which pulls the blood and the lymph towards your chest. Well, that's where your heart is. That's what you want. And we know this works because is the blood still going back to your heart while you're sleeping? Yeah. Why? Because you have to breathe while you're sleeping. And while you're breathing, you are also changing the shape of your chest, even though slightly, but it's enough to create a suction that pulls liquid towards the heart. 10-4? So just like your veins. And even smooth muscles in the large vessels will contract just like in your larger veins. They've got smooth muscle. They've got 3 layers. Remember, I made a boo-boo in the last video and said there's only 2 layers. No. They've got 3 layers or 1. Got it? So the smallest capillaries, whether they're blood capillaries or lymph capillaries, have 1 layer. They've got to be small so they can pull in the stuff. Got it? And then the bigger ones have 3 layers with a muscle layer and a tunica adventitia for protection. Cool beans? And there's your one-way valves again. How's that? Work for you? Okay. Stop me if you have a question. Seriously. Alrighty. So, what is the purpose of your lymph nodes and tonsils and your appendix? Okay. Let's go. That's a cool picture. There's a little lymph node right there. One thing I do want to make sure you understand, I don't know if that's in here or not, it might be on your test. See how many incoming afferent vessels and how many efferents? Okay, think of a traffic jam. You had a 4-lane highway coming down to 2 lanes because of construction. Is the traffic going to speed up or slow down here?
Slow down.
Slow down. So the water coming through the liquid is going to slow down. Why? So that inside these little follicles, where our T cells and B cells are doing their job, they've got time to inspect what's coming in. They've got time to identify good guy from bad guy. They've got time for the macrophage to eat up what needs to be eaten so that what comes out is cleaner than what came in. But we had to slow it down in order to get that job done. Because remember, is it only one lymph node? No. A little bit further down, there's another lymph node. And a little bit further down, there's another lymph node. So we have multiple times that we can clean out the lymph. So by the time it does get to the subclavian veins, it's just basically water. Then of course, there's chemicals in it, but we've taken out the dead cells that we might have picked up along the way, and we've gotten rid of all the pathogens. Got it? Because the last thing we want is pathogens to be in the blood. Because when they multiply in there, you're going to get septic. And you might get what? Septic. What?
Shock or?
Yeah, septic shock. Got it? Anaphylactic shock is a chemical that you've eaten getting into your blood, and all your basicles release histamines. Septic shock is a chemical released by bacteria that causes your histamines to be released. You get the same situation. Your blood vessels open up, your blood pressure goes down, and you go, oh, that's it. You know what I mean, Vern? All right. Okie dokie. See? Filter. All right. I have video on all that. What are we talking about? Tonsils. There we go. Okay, yeah. Tonsils. Okay. You've got several sets of tonsils, and there's pictures of that for the lab practical as well. Oh, looky here. Look at those infected tonsils. Got it? That's pus. What is pus made out of? Dead and dying pathogens, dead and dying cells of your tonsil tissue, as well as dead and dying white blood cells. It's just a big old holocaust of living and dying. And because the pathogens are dividing just as fast as we can send white blood cells into fight, the battlefield gets bigger. Got it? If we were able to beat the bad guys, our tonsils would stay small. Mm-hmm. But they get bigger, filling up with pus, all the dead guys, because they're multiplying as fast or faster than we can send in the cavalry. Does that make sense? What happens when this pus hardens?
Tonsil stones.
Tonsil stones, okay, which have to be removed, okay? Now, I'm lucky, I haven't had tonsils since I was 5, so I've never had a sore throat since I was 5. Neither have I had earaches, which is the reason why my tonsils were taken out. But I've got a student, I had a student in here a couple of semesters ago go, oh yeah, when I get tonsils, I just stick my finger back there and pop them out. I'm going like, I think I'd be choking with my finger all the way down in my throat, but they're used to doing it. But yeesh. Okay, what do these characters have? Crypts. Just like when you're trying to bury a loved one, you put them in a crypt. Think about Jesus. They were afraid, the disciples were afraid that people would steal his body, so they went to a mountainside with a cave in it to put his body. That's a crypt, because then they covered it with the big stone that was rolled in front. That's all a crypt is. And if you build a building to put your loved one, that's called a mausoleum. But it's basically, the word crypt means hidden. Got it? So, that's a crypt. These things here, what they're hoping for, the reason that this works, is that it's here, in the back of your nose, in the back of your throat, in the back of your tongue, and you actually have one here called the tubal tonsils, where the eustachian tube empties from your ear. And these crypts catch the bacteria, and there's white blood cells down in here to eat them up, and macrophages. Got it? So you want them to fall in a pit, basically. Alrighty? Trouble is, if what's in the pit multiplies faster than the good guys who were fighting, then you get your inflammation and all the pus and stuff. That for? All right. So that's why some people have had their tonsils all their life, no problem. You know, I was having earaches every winter. And this is why a sore throat leads to an earache, and an earache leads to a sore throat. Because that's a tube right here. And so if bacteria are attacking your ear, they'll climb down and attack your throat. Or if they're in your throat, they'll climb up and attack your ear. All right? And since I was having all these things, my doctor, the pediatrician recommended to my parents, get these tonsils out. And they not only took the ones here, they took the ones up here too. Okay? And, okay, now I can't find bacteria in my throat. Well, guess what? There's also no place for them to get trapped in a crypt. That's why I've never had strep throat. I've never had sore throat. Okay? Which is good for me. All right? I enjoy it. All right. Cool beans? You have the same kind of things in your intestines called the Peyer's patches. Okay? There it is. That's the Peyer's patch. Got it? And all these little characters in here, those are the white blood cells. And they can come out and they can wander around inside the columnar cells of the villi, as well as in the stroma of the villi. And their job, here's a crypt. Look, see that crypt right there? And here's another crypt right here. For the bacteria to fall in. Why? Because the bacteria might have caught a ride on your ham sandwich. And do you want them to go into your bloodstream? No. So all these guys are positioned to try to stop. Got it? With the same kind of thing like you have with your tonsils. Crypts and groups of white blood cells. Got it? Of various kinds. The macrophages and the T and the B cells. Alrighty? Cool beans? Alright. Oh, look at this. There's your lacteal. And there's your lymphatic system in green. The lacteal is where we absorb the fats, but your blood vessels, the capillaries and whatnot, is where we absorb the amino acids and the carbohydrates. Then 4? Okay. All right, let's see. We'll do the spleen in a second. Oh, then diseases. What else was on that list?
The appendix.
Oh, okay. I can just tell you real quick. Your appendix works like this. It may be sticking out of the end of your large intestine, but it's like a big crypt where we want the bacteria to go so we can eat them up with the white blood cells. What happens when your appendix is about to rupture? Just like your spleen filling up with good guys and bad guys, same thing with your appendix. And why don't you want it to expand and pop?
Send the bacteria into your...
all the bacteria are now going to be in the peritoneal cavity, and you're going to get peritonitis. And that could kill you in a matter of days. Okay? So that's why, ow, it's hurting. Well, then go. They can do a quick CAT scan or something and see what your appendix is doing, and schedule you for emergency takeout. And I've heard that from plenty of students. You know, it hurt on Saturday, you know, they couldn't take it. They went to emergency on Sunday, and man, they were operated on Monday morning because they can't wait much longer. Cool? All right. So, red and white. Oh, yeah, I knew that was in here. Okay. Your spleen. Liver's here. Spleen is here. Okay? Your spleen has 2 very important functions. As we learned in the blood chapter, this is the graveyard of the red blood cells. That's where they go to be taken apart. Alrighty? Well, I wonder which pulp contains red blood cells. The red pulp. Got it? The areas that are kind of squishy, but that are red in color. So that's the graveyard of the red blood cells. So what's the white pulp? No, not the graveyard of the white blood cells. This is where they multiply. Got it? The white blood cells that are in here are just waiting to be told, we need more of you. So, quick, multiply. We need more of you. Quick, multiply. See, you're designed to go after this kind of bad guy. and that's who's attacking us. So multiply yourself. Or one day you need to be multiplied. Does that make sense? So that's why it's white pulp, because it's right along this area here that we are proliferating, growing the white blood cells that we need for that time. Okay? Have you heard of having your spleen removed? Yeah, okay. And that could be from trauma. Sometimes it's a seat belt that was too tight. When you got hit real hard, it pulls in and tears your spleen. Well, your spleen being pulpy, that's like trying to sew together oatmeal. It ain't gonna work. 10-4. So if it's damaged too much, you might have to what? Remove it. And so that happened a lot in hockey. You know, when somebody high sticks you right up underneath your rib cage. Yeah, here you tear your liver, but thank goodness your liver can repair itself, but not your spleen. Got it? And a lot of them have their spleens removed. That's why they have to watch. Don't high stick each other that much. And so, who will take over for this? Well, your liver can take over for this. Your liver will then be the graveyard for the red blood cells. 10-4, take them apart. Not your white pulp. So you're just going to have to not be infected too much because you won't have enough white blood cells building up. Got it? In one little place. You have to wait for your white blood cells to proliferate in the bone marrow. Okay? Where they're born. All right, this is good. And last is lymphedema and elephantiasis, right? Okay. Well, if your lymph is blocked from coming back, what's going to happen?
It's going to swell up.
You swell up. So if your lymph is the one that's causing the blockage, it's called lymphedema. Got it? Otherwise, it's the regular edema, which is too much coming out of your capillaries from high blood pressure, pushing out too much water. And where is that usually? Down here. Okay? Because gravity is pulling your blood down. This is elephantiasis. It's a little bit different. And it's called elephantiasis because when this is in its worst condition, your skin looks like an elephant's skin. It's all rough and scaly and dark gray. And here's what it is. It's basically a parasite that you get through the bite of a mosquito. So somebody else has to have it for it to come here. Does that make sense?
Yes.
If it's not in the area, if it's not in the population, you can't get it from a mosquito bite. We don't have malaria here in South Carolina, so no matter how many times a mosquito bites you, you can't get malaria because she has to pick it up from somebody with it. Therefore, it's a little parasite. It's a single-cell amoeba-like creature called a trypanosome. Alrighty? In malaria, they want to live inside your red blood cells. Got it? Which causes the red blood cells to pop when the babies are being born. Little baby worms are being born. They pop, and of course, what happens? Out comes the heme. Heme turns into bilirubin. More bilirubin than your liver can handle. You get jaundice, i.e. yellow fever. Well, with this, these trypanosomes don't want to be in your red blood cells. They want to live in your lymph nodes. So if they live in the lymph nodes that are inguinal, look at how one leg blew up. Got it? And because there's not much circulation going on, it starts to necrotize. Your skin starts to die. Got it? And when it gets really nasty, it'll start looking like thick, wrinkled gray skin. Hence the name elephantiasis. You look like an elephant. Got it? Look at this poor guy. That's an actual picture. Notice it's an old daguerreotype black and white photo, meaning from the 1600s, either from the 17 or early 1800s. It's not anything modern. But where do you think the parasites are living? Here. Because guess what this is? His scrotum. His wee-wee is down inside here somewhere. But all the fluid is backing up. And see in his legs? Because here in the inguinal region is where we have all those parasites living inside the lymph nodes and blocking the flow back. Got it? And you can see it started happening in his arms too. 10-4? So that's what elephantiasis is, okay? It's a blockage of your lymph nodes. Now, ladies, you can have a blockage of your lymph nodes leading to lymphedema. I know I have a picture in here somewhere. Here. She had breast cancer. Got it? You take out the breast because of the cancer in there, radical mastectomy. And when they do that, they also take all the lymph nodes out of the axillary region. Because what does lymph do? It picks up tissues and brings it in. Got it? What if those tissues happen to be cancerous cells? So just to make sure, we take this out too. 10-4? Well, what happens? Now this is gone. Can I drain that arm of lymph? No. And one arm gets edematous. This is edema because of the lymph node being blocked from surgery. Because we took them all out. Got it? Closed it off. Got it? That's lymphedema after radical mastectomy. Radical mastectomy means it's radical to take the whole body part out. Got it? Otherwise, it's called a lumpectomy, where they just cut out the lump of cancer. Okay?
And quick question. So
Yes.
you said when you see that, you have to wear a compression
Sleeve, yes. Mm-hmm.
and that pushes the fluid
That pushes the
up?
fluid up for you, artificially.
Does it just get picked up by the lymph nodes in other spots, or does it?
Or picked up by blood vessels in the other spot. Yeah, it's really amazing how your body can readjust. Even when you have your great saphenous vein removed, because we're going to use that as a bypass for your heart, for the coronary arteries, I'm going, oh my God, wouldn't you have edema in that one leg? No. The blood will find its way into another vessel and get back. You don't have that happening. Okay? Now, back in the old days, you might have had a nice big scar. Because they would cut you from down to bottom and tease out that. Now they know that vein is so tough, cut here, cut there, and pull it out.
Jeez.
So you don't need to, you only got the two little cut scars, where you went in and cut that great saphenous vein.
That's wild.
Now, what is something, this popped in my head. What is something you have to be careful of when you use the great saphenous vein as a bypass?
The valves?
Yes, you got to flip it upside down so the valves are going in the right direction. Because the valves are going this way, right? Well, your coronary arteries go this way. So you got to flip it over before you sew it in. Or the valves are going in the wrong direction. You can't get the blood from the top of the heart, where the aorta is, down to the bottom of the heart. Okay? All right. So, but yeah, that's definitely. Okay? Lymphedema. All righty? And yeah, a compression sleeve would help. But some people either don't want to wear it, or they say, I don't care, Who's going to look at me? I'll just wear a big sleeve, So, I've seen people like that. Okay? Cool beans? Wow, is that 21A?
That is it.
How about that? Any questions from the audience? Are we good? All right.